In this section, we're going to be dealing with dividing polynomials, and then later on we're going to introduce probably a new topic to you. Now, dividing polynomials should be something that you've seen before, but now everybody hates it. They always make a fuss, so we need to go over it again because it is important whenever you get to college algebra. You'll absolutely need to know how to do the division of polynomials. All right, so as we're going through this, I want to kind of present this sort of as kind of like categories, or so you have different options. Our first situation is if we are dividing by a monomial. So just to refresh everybody's memory, a monomial is one term. Can be either a number or a letter or a multiplication of a number and a letter. So here we have, we're dividing by a monomial. So our procedure then for doing this division is actually a little bit simpler than long division. What we're going to do is we're going to use the idea of just how in the world do you add and subtract fractions. So let's say that we had a problem that looked like this, that said 1/5 plus 2/5. We're going to kind of work backwards so we can see what's happening here. If you were adding fractions that had the same denominator, normally we would just say, well, that's going to be 3/5. But what's really happening there? Well, how did we get this 3? We did the 3 by adding the numerators 1 plus 2. And then that became 3/5. Now we're so used to doing this, we don't have to do this middle step here. We just kind of bypass it. But when it comes to polynomials, we can't bypass it. All right, so if we can add and go forward, we should be able to go backwards also. If we can put these two fractions together by adding the numerators and then keeping the same denominator, then we should be able to separate them back out as they originally were. That's the concept that we're going to use here with the dividing by a monomial. I'm going to rewrite this. Instead of as a single fraction, I'm going to break it up into two fractions. I'm going to break it up into 8x squared over 4x, and then plus 12x over 4x. Now, keep in mind, I can do that because these have the same denominator. And if I were to add these fractions together, I would have to add the numerators, which would get me right back here to where I started. But now that I have these separated out, this just becomes a reduction problem. You're going to reduce each one of these fractions. So in our first fraction here, 4 will go into 8 2 times. And when we divide like bases, we subtract the exponents. So this becomes 2x plus. Now here again, we're going to work with the number parts first. So 4 will go into 12 3 times. And then dealing with our x's, we have, you can either use your rule, which would say divide like bases. We would subtract the exponents. So 1 minus 1 would be 0. Or you can look at it as just reducing. You've got an x on top and an x on bottom that will cancel each other out. So our second term is just a 3. Therefore, the answer to this problem, to this division problem, is 2x plus 3.